Yeah. Okay. So today lesson we're going to look at easy way to find derivative of a function. Many students are facing a challenge of differentiating a function. But today, after going through all this tutorial set, you'll be good to go. Now, I'm your facilitator, Ishmael Achampo. So let's look at it. Now, for you to differentiate derivative of trigonometric function, there are easy way or trick way for which you will not stress. It doesn't matter either you're a mathematician or not. We know that we have three trig functions. The three main, we have the sine, let's take sine s. The s is my angle, someone can use theta. Let's take cos s. Then tan s. We know this is the three main trigonometric function. But for it to be easy, this is our function. Now let's look at the derivative of this function. Take note, if I have sine s, anytime I have 1 over sine s, will give me what? That's cosec. That's 1 over sine s. Also, 1 over cos s. If I have 1 over cos s, that will give me what? The sec s. Because we are going to use this one, the cosec sec. Then, if you also have 1 over tan s, and this will give you what? The cot. We are going to combine this one. That's why I first introduced this one for you. So, for us to be easy, we know that 1 over sine is cosec s. 1 over cos is sec. And 1 over tan is cot. But I'm rather starting from this side to the top. So I have 1 over tan first. That's what? Cot s. Then I move to the next one. 1 over cos is what? Sec s. Then 1 over sine is what? Cosec. So after this, I have just derived 6 trigonometric function here. Now, how am I going to differentiate all this one? It's easy, as I said earlier on. Anytime the function starts with c, just negate the function. So for derivative, all the one that will start with c, negate it. So the first one, s, it does not start with c. Look at cos. Cos starts with c. So I have to negate the derivative. Tan does not start with c. Now let's look at the cot. Cot starts with c, so that derivative will be negative. Can you tell me the one that will start with c? Very good, cosec. Cosec starts with c, so we negate the derivative. After the first step, then your second step, I'm just going to interchange the sine and the cos at the derivative. So I'm going to interchange these two. So first one, sine s will be what? Cos s. So I'm just interchanging the two. So the cos s will be what? Your sine s. So after you interchange these two, now the rest, I'm just going to count 2 steps downwards. So I have tan s. I'll just count 2 steps. So let's count 1, 2. So that function, you just multiply the function by itself, or the same as squaring that function. So I have tan s, so 1, 2. This is my 2 steps downwards. So I'll just multiply this function by itself, giving what? sec s times sec s giving you sec what? Square s. Follow. Now let's look at the chord. The same thing, 2 steps downwards. So I have 1, 2. Now I get cosec, so you multiply the function by itself. That will give you what? Cosec square s. Now let's take the next one, the sec s. Let's count the 2 steps downwards. So you have 1, 2, but there's no function here. Therefore, you have to rather count it upwards instead of downward, because the 1, 2, there's no step here. Therefore, if there's no function, count it upwards. But before you count it upwards, you find that function. Then you multiply by the function that will be after the 2 steps upwards. So this one, I cannot count 1, 2 downward, but rather upwards. Therefore, I'll write the function first. Sec s. Let me count the 2. Then 1, 2. So there's the 2. So I'll multiply by that function. Tan s. Now let's take the cosec. The cosec, I cannot count 2 steps downward because 1, there's no function here. Therefore, I have to move upwards. And for you to move upwards, you just pick the function first. So cosec s. Now let's count the upwards. 1, 2. So you have what? Cot s. So after you get this all about the derivative of this function, the trig function. When you differentiate sine, you get cos s. When you differentiate cos s, you get negative sine. When you differentiate tan, you get square s. When you differentiate cot s, you get negative cos s square s. The same thing. So after going through all this one, the derivative of trigonometric function will be easy and it will be good to go. Now let's look at how I'm going to apply it. So let's take sine. If f of s equal to sine s, assume that we should find the derivative. Take note the prime the same as dy ds, or the derivative of s. So anytime you see the prime the same as the derivative. Now how are you going to find the derivative of this one? The same as differentiate the function first. So you have f prime, or derivative of s, equal to. So when you differentiate the sign, you get what? If you remember, we first do it here, sine, cos. So we say just interchange it. So you get what? Cos s. Before you can do, sometimes you have to just do this one somewhere so that it will guide you. So I'm just doing this one here so that it will just guide you. So you have the cos s, tan s, cot s, sec s, cosec s. You see, you interchange this one, but when you start with c, you start with negative. Interchange it, so sine s, downwards, so 1, 2. You multiply it by itself. Sec square s, downwards 1, 2. Cosec square s, 1. There's no number, so rather upwards. But you pick the function first. Sec s, then 1, 2 under tan s. The cosec, there's no function, so upwards, as we said earlier. So cosec s, then 1, 2. So cot s. So you want to differentiate sine s. First, so just differentiate the function. When you differentiate sine, you get what? Cos s. So cos s times, you differentiate only the angle. So when you differentiate the angle of s, the same as d over ds of this one. So you differentiate the function itself, maintain the angle times the angle. So the same as cos. When you differentiate s, you get what? Just 1. Now, assuming here it's not s, let's take 2s. So you have y equal to 2 sine s. And we want to differentiate. So you have dy, then the function is what? Respect to s. So dy ds. First, we say you differentiate the function here. So when you differentiate sine, you get what? Cos. Cos. Then you maintain the angle. Times, you differentiate only the angle. So when you differentiate 2s, you get what? 2. So that this will give you, note that you cannot multiply this by this, because this is angle, but this one is just a number. So you cannot say 2 times 2s will be 4s, no. Because here it's just an angle. So you multiply by the coefficient. So 2 times the coefficient, that's 1. Now it'll be 2, then maintain this one. Cos 2s. Another one. Let's differentiate this one. Tan s squared plus 6. So we say you differentiate the angle first. When you differentiate tan, you get what? Cosec squared. So here, there's the angle, the s. So you differentiate tan, you get cosec squared. Also, you get the sec squared. Then the s, that's the angle. So you have the angle s squared plus 6. After that, then you differentiate the angle. So when you differentiate this angle, you get, that you differentiate s squared. And to give us what? 2s. Now when you differentiate the constancies, you get what? 0. Take a look, so you cannot multiply this by this, because this is angle. So you just bring it, multiply by the coefficient here. So the y, or let's pick y prime. So therefore, y prime will give us, you can bring this one first. 2s sec square s squared plus 6. So these are just a summary of how you differentiate the trig function. Now, let's look at if it is inverse. How are you going to differentiate the inverse function? First one, you just go by the same thing. How? Assuming instead of, let's take tan s, they rather make it tan inverse of s. So this is about the inverse. So our next lesson, we are going to look at how to differentiate the inverse function. But this one today, we just look at how to differentiate the sixth trig function. When we are integrating, the same thing. So integration, instead of here you differentiate to get cos, integration to be reversed. So the differentiation is from here to here. By integration, you pick here to this side. Differentiation from here to here. By integration, you pick from here. So we are going to look at also how to integrate with the same approach. So thank you for joining us today. Our next lesson, we will look at how to integrate in the inverse function. See you.